Alright, so I think this is recording. Let's take a look at these remaining problems here. And we have to read the directions very carefully because later on in later homeworks the directions are going to change just a little bit. And if you confuse the directions, well, you're not going to get the right answer. They're giving us an angle measure of 510 degrees and asking us what quadrant does it lie in. Well, I'm in degree measure. I know the boundaries for my quadrants are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. So I know that this 510 is completing more than one revolution. So coterminal angles, I can add or subtract complete revolutions. I can add or subtract 360 degrees and get an angle that has the same initial side and same terminal side. So 510 degrees is coterminal to 150 degrees. They lie in the same quadrant. It's difficult for me to look at 510 and see what degree it is, but it's extremely easy for me to look at 150 degrees and recognize it's bigger than 90 and smaller than 180. So this is quadrant 2, and you can put the number 2, or for some reason it's traditional to write these as Roman numerals. All right, now if this is the coterminal angle, and if this is 150 degrees, a reference angle is always an acute angle. If it's in degree measure, it's going to be between 0 and 90, and it's always the angle that this terminal side makes with the x-axis. So this is the angle measure that I need to figure out, and since I'm in quadrant 2, I have that chart that says anytime you have an angle measure in quadrant 2, that the reference angle is going to be 180 degrees minus this coterminal angle that's in quadrant 2. Not the 510, but the one that's between 0 and 360, the 150. So 30 degrees is an acute angle, and look how reasonable it is. 150 degrees and another 30 degrees is 180. So I'm pretty confident that 30 degrees is the correct reference angle that I want. Now, for the trig ratios for this problem, it's not wanting me to take the trig ratios of this number. It is going to be related, we'll see later on, but these are asking me for theta, and it's calling this reference angle theta, so it wants me to take the sine of 30 degrees. Well, I know that already because 30 degrees is one of my special 30, 60, 90 degree triangles, and I know that I have 1/2, 1, square root 3, if you can read that, square root 3 over 2. So the sine of 30, the sine of theta, when theta is 30 degrees, this is saying what's the sine of 30 degrees, and that's 1/2. And this is saying what's the cosine of 30 degrees, and that's the adjacent over the hypotenuse. That's square root 3 over 2. And the tangent, the 1/2 divided by the square root of 3, that's the tangent of 30. Remember, you've memorized that either also in that chart. 1 divided by the square root of 3 rationalizes to the square root of 3 divided by 3, and that's our answer here. I'm running out of room, but there's our answer for this number 13. Now, the rest of these problems are going to be similar, so I'm going to do them on the same video because I need to get out of here, and it takes a lot of time to cut and paste and do these videos one at a time versus all of them. 315 degrees, that's nice. I don't have to worry about coterminal angles. That I know that 315 degrees is bigger than 270, smaller than 360. So I know that this angle of 315 degrees is wrapping around here, and I know that that's quadrant 4. For some reason, I've on several mistakes now, I've kept calling this quadrant 3, and I don't know why, because this is 1, 2, 3, and 4. But I keep making silly mistakes. The reference angle that I want is right here. So when you're in quadrant 4, to determine that reference angle, it's 360 degrees minus this coterminal angle minus this 315. So my reference angle, 360 minus 315 is 45 degrees. Okay. And now 45 degrees is I can get that from a 45, 45, 90. I know that if I have 45 degrees, which is also pi over 4, by the way, that these sides are congruent, that there's square root 2 over 2, and my hypotenuse 1. I know sine and cosine are the same value because the opposite side and the adjacent side are the same. The hypotenuse is 1. I know this is square root 2 over 2, and this is square root 2 over 2. And since the tangent of theta, and remember theta is 45 degrees, I've got the opposite over the adjacent. I've just got the number 1 right there. All right, so let's keep going. Now I'm in, oh, I just knocked off my microphone off my head. I don't even know how I did that. I have 11 pi over 6, and I'd like to determine what quadrant that's in. Well, so with the denominator of 6, it's hard for me to compare against pi over 2, against pi, and against 3 pi over 2 and 2 pi to see which quadrant where this lies in. But with this denominator of 6, why not write pi over 2 as 3 pi over 6, because I'm multiplying by 3 over 3, and the same thing here, multiply by 3 over 3, and I've got 9 pi over 6. Make this 6 pi over 6, multiply by 6 over 6 to get a denominator of 6, 12 pi. Well, now I can easily compare this 11 pi over 6 and say it's smaller than 12 pi over 6. 11 is smaller than 12, but bigger than 9. I know I'm over here in quadrant 4. I know this 11 pi over 6 wraps around counterclockwise to there. So I know I'm in quadrant 4. Now the reference angle that I want, whenever you're in quadrant 4 and you're using radian measure, you want 2 pi times this angle measure. So my reference angle is just the subtraction 2 pi minus 11 pi over 6. But I need to rewrite 2 pi with the denominator of 6. I need to multiply by 6 over 6, and 12 divided by 6 is 2, and 12 pi minus 11 pi is just 1 pi over 6. So my reference angle is pi over 6. All right, so let's shrink this up, and pi over 6 is, 30 degrees. So let's write my 30, 60, 90 degree triangle, but only with radian measure. If this is pi over 6, this one's pi over 3, and this is 1/2, and this is square root 3 over 2, and this is 1. So the theta, this is what we found theta to be. So the sine of theta is 1/2, and the cosine of theta is the square root of 3 over 2, and the tangent of theta is 1 over the square root of 3, but that rationalizes to square root 3 over 3. And we need to be able to do that quickly and efficiently. All right, so this negative 14 pi over 3 is definitely, it's not between 0 and 2 pi, it's negative. So I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, with the denominator of 3 and this denominator of 2, I need a least common denominator of 6. I need to rewrite this negative 14 pi over 3. I need to multiply by 2 over 2, negative 28 pi over 6, and 3 pi over 6, and 9 pi over 6, and 6 over 6 here, 12 pi over 6, because I multiply by that, and then just write this as 6, sorry, I'm getting so sloppy because I'm trying to hurry, 6 pi over 6. So now I'm ready to sit there and say, well, first of all, that's negative, but now I have all the same denominators, so I just need to start adding positive 12 to this negative 28 until I can see what quadrant I'm in. So I can sit here and take this negative 28. The calculator's only good if you punch in the right numbers. If I add 12, that's not enough. It's still negative. If I add 12 and a second revolution, that's not enough. But when on that third revolution, I'm getting 8. So 8 pi over 6 is my angle, my coterminal angle of interest, and I'm going to reduce this to 4 pi over 3 because I don't need now to, well, 8 pi, I guess I can, the last comparison I need is 8 is bigger than 6 but smaller than 9. So 8 pi over 6 is in quadrant 3. Quadrant 3. But my reference angle, I'm going to reduce 8 pi over 6 to, that is not the reference angle. That helped me, that was the coterminal angle that helped me determine the quadrant. My reference angle is always an acute angle that's between 0 and 2 pi. This is my reference angle. When you're in quadrant 3, to find your reference angle, take that coterminal angle of 4 pi over 3 and subtract pi from it. And let's write pi as 3 pi over 3. So now this, and this is an equal sign there, 4 minus 3 is 1, and 1 pi over 3, well, hey, I'm just going to write that as pi over 3. So there's my reference angle. It's an acute angle. It's the angle that's made with the x-axis and this terminal ray. Now, it wants me to take these trig functions, find the ratios of pi over 3. Well, I have those ratios memorized in the form of a 30, 60, 90 degree triangle. And if this is pi over 3, that's 60. If this is pi over 6, that's 30. They're complementary. And I know that this is 1/2, that this is square root 3 over 2, and this is 1. And this is the angle theta. So sine of theta is square root 3 over 2. The cosine of theta, adjacent over hypotenuse, is 1/2. And the tangent, square root 3 over 2 divided by 1/2. The 2's cancel, and I just have the square root of 3, right? All right, so hey, that's it. I hope that helps, and I'll talk to you later.